Here we go with session 5 of day 1 of the 2025 RNG Technical Symposium. I'm Paul Green. I run a biogas advisory business, and I drive the website biogas.tv. In this session, we're going to hear from Bernie Sheff of Burns McDonnell about operating anaerobic digesters. You may have questions on the fly. You can ask in the chat or the Q&A box, and we'll have some time at the end to go over questions as well. Later today, you're going to get an email from me pointing to the slides from this talk on my website, and a video of this will be available by the end of the week on biogas.tv. So with that, I'd like to introduce Bernie Sheff. He brings 37 years experience in the design and operation of digesters and nutrient management systems. 37, in case you missed that, 37. His first digester started in December 1991 at a packing facility in Plainwell, Michigan, and is still running to this day. He's provided troubleshooting for digestion systems around the U.S. and Europe. Currently, Mr. Sheff is currently in his 11th year as the chairman of the American Biogas Council and as a PE engaged on projects across North America. In 2024, he accepted the position of convener of the ISO TC 255 WG1, the Biogas Working Group. He's currently an associate technical consultant for Burns and McDonnell. So with that, my friend, my guru, Bernie Sheff, the floor is yours.
Great. Let me hit the share here. All right. See the slides? All good?
Yes, good.
Great. I have to say something before we get started here. This is beyond an honor. There's very few people in this industry that I have such great affection for than Paulie. He's my guy. There's very few people like him in this industry that are really versed across the board, and so this is really an honor to be a part of something that Paul would put together. Thanks, my friend. I appreciate it.
Yeah, we're having fun, sharing some love, and we're also getting encouragement to do some more jokes in case there's any vacuum on dead air. So okay. we can take this any number of ways, but thank you.
You know, I think what we need to do is for Biogas Americas put 2 ferns on the stage and you and I in between it. Now that could be fun. We could have a good time there.
It's been a long time since we all agreed, we're talking about manure. How can we take ourselves too seriously? It's manure we're talking about.
Well, I mean, this is really a personal problem, what you're talking about here. I mean, these are people who were left alone a long time as a child. So
right.
Probably what caused most of this. So hey, we'll try and get through this without cracking too many jokes. But again, a great honor to be here today. So Paul asked me to talk a little bit, sort of take a 30-minute chunk out of this day and talk about digester operations. And I was watching all the presentations coming up, and I'd imagine at this point, some of you probably don't want to talk about digester operations anymore, and some of you are sick like me and can just keep doing this for hours. So in 30 minutes we can't do a lot, but I wanted to hit on a couple things, a couple really points that I felt are really important in digester operation. So we're going to talk about some daily operations, and then we're going to talk a little bit. I think we're going to focus in more on key insights on substrates and a little on site management, some overviews there. But there's really, I mean, the ABC spends an entire week, 40 hours, 5 days of classes and tours and all these things to get a operator certification. So to do it in one day is going to be tough. So Paul talked about me, and I don't need to. This is in case you needed something to like put down at the bottom of the bird cage or something to throw darts at later on. But yeah, I've been doing this a long time. And as Bland brought out, my Spartans, I was the recipient of the Lifetime Achievement Award from Michigan State University in athletics last year, which was not because of my athletic prowess. I'll leave it at that. So what we're going to talk about today, I've got a couple little cool slides that we're just going to blow past quickly that I want you to, if anything else, you'll have them in your back pocket when somebody comes to your site or when somebody comes in your office and wants you to explain this in 2 minutes. You should be able to just pop these slides up. We're going to talk about substrate as potential energy, which is an entire course that Craig Freer and I teach for the American Biogas Council as far as continuing education. Then we're going to talk a little bit over system controls, and then some insights. And then Paulie wanted me to talk about a couple projects, good projects that we've worked on to either, well, I guess we didn't work on these together, but some of the stuff I've done in the past is a little bit of an overview. So we'll get to that towards the end. So a couple neat little slides. This is a slide from the ABC. And basically, again, these are more to have in your back pocket. If anything else, I really like these two. Is a nice breakdown of, and that the digester doesn't have to be a CSTR. It can be a covered lagoon. It could be a plug flow. It can be a mixed plug flow. But in general, a nice slide there for you to have. This is a second one again. I think that this is just a neat little slide that you can have in your back pocket that talks about anaerobic digestion, sort of in a complete overview, which is something you might need when again, when that tour comes by your facility and you'd like to put something up on the wall to give them a little primer. So when we're talking about anaerobic digestion, and most of you might know this by now, but it is indeed a 4-stage process. This slide we put together here is I thought it put some nice words, and it'll marry up nicely with the next slide coming up. But your hydrolysis, right? It's where your complex organic molecules or your materials, your fats, your proteins, your carbs, many of these things are broken down into your smaller molecules, right? These are your sugars, your amino acids, your fatty acids, things like that. Then acetogenesis happens, which is this is a bacterial process where the byproducts, or what the products that came from the hydrolysis, right? That these are converted into acetogenesis. They're converted over into acids. The next step is where we take those acids, and again, this is all bacteria doing the work, and these acids are further broken down to produce the acetic acid, hydrogen, and carbon dioxide. And then our fourth step, and again, what kind of a crazy person would put the energy at the very last step after this is essentially, you've got you've got 4 steps up front, and all of them are uncontrollable, and you've got 1 step down here at the end, the methanogenesis, which is I always like to use that's the old man of the bunch. That's grandpa. He's in the home, and he has to get exact amount of food every day, and he's not a bacteria. He's actually an organism. He's the oldest organism. Archaea means the ancient one. So when we look at this in a different way, and this is a slide from the American Biogas Council that I've been using for years, and I just thought again, take the words from the previous slide, and then that should help you explain what's going on here. Check out that very end step, though, going from 3 to 4A and 4B. You see something interesting going on? Right, 25%, up to 25%, and maybe more. It depends if you can feed more hydrogen into the system. Think about that. You feed more hydrogen into the system, you can get, there's this other pathway that's there and it's doing its job. So you have acetic acid or hydrogen and CO2 that are both being converted by the different, there's a couple different forms of the archaea. Methana sarcina is the one using the hydrogen. Did some tours in, if you ever get a chance, go to Denmark and see what they're doing. Went to one facility. When they had excess electricity on the grid, they would use the windmills to turn hydrogen generators and feed the hydrogen into the digester. Somebody's figured out something, hey? Somebody's a step ahead of us. That means we just got more to learn. Okay, I want to talk about substrate now as potential energy. We understand just amazingly by you've already gotten through, you know how anaerobic digestion works. I want to really get into this because as an operator, turning a wrench or, pulling out a pump or keeping the upgrader running, that's important. That's mechanical. But understanding what's going on in that tank, right? Understanding what's going on there is going to make the difference between you running a successful facility or you having problems, right? So I want you to start out, and this is the basic premise. You must understand that everything can be considered volatile solid or volatile if it will burn. If it burns, if it makes heat, right? It is actually, by definition, it's volatile, right? Unfortunately, the types of ES are completely different when considering their viability and their ability to make, for the digester to make methane from them. This paper, go get it. Right after I'm done, I want you to drive right. I want you to get online and get this paper and read it. Doesn't matter if you run a food waste digester, whatever you're doing, read this paper. One of the best ever written. She's tremendous. Dr. Ann Wilkie, just fantastic. You read that paper, you go back to this, what we're saying right here, you must understand this. Our entire industry is run by a bunch of bugs. That's it. The bugs run it, right? That's where our energy comes from, is bugs, bacteria and organisms that work together in a 4-step process in order to make methane. So from that standpoint, going forward in your operations or anytime you're designing a digester, if you're an engineer or operator or process control, I want you to always look at the fact is that any substrate that you're going to be dealing with, I want you to look at it from a standpoint of a 2-layer cake. You got a layer of cake, you got a layer of fruit, and then you got a layer, the second layer of the cake, but it's not cake on the bottom. Okay, the bottom of that is going to be wax-coated carbon or wax-coated cardboard. Okay, bugs can't eat it, but it certainly burns and makes gas. It floats, doesn't separate, it comes out of the system, right? Look at the BMP, 0, right? Conversely, look at that. Look at the sugar. What happens when you put that piece of cake in the reception pit going into the digester? Cardboard comes out. The sugar immediately jumps all the way to the second step. It completely dissolves immediately and goes right into, and it starts making gas quickly. Right? The cake might spend some time before it finally breaks down, but your fruit might be there for a day until it finally is completely broken down and it gets into the system. When you get a BMP for something, you always need to be looking at it and breaking it down in your head, right? So this, I know that there's something in this. It's a high sugar substrate or it's manure. Well, if it's manure, I know that 45 to 50% of it is going to be a fiber, maybe more, that doesn't make any energy, right? So that's why understanding this is so important. Always think about what in the substrate that's coming to your facility, what makes gas and what can't make gas. And the ultimate arbitrator is the bug. Bernie's bugs. That's what's going to make the decision on what makes gas. So that's why we run biomethane potential. Now, Paulie asked me to add a couple things in here to talk about this, the difference between BOD and COD. So you know that BOD, biological oxygen demand, is what you determine when you take, it's usually from wastewater, but you can do it with pretty much anything if you can get it dilute enough and you get it into your BOD bottle, and you can and you have bacteria in there, and those bacteria are going to break down the biological, the biomass. They're going to break it down, and the amount of oxygen that they need in order to break this material down aerobically, that's BOD. COD is a lot like taking that candle that I showed you and burning everything. There's no aerobic bacteria that can eat the cardboard and eat the wax cardboard. They're not going to do that, right? They're going to eat the sugar off the sides. COD, however, if you put that in a COD, the COD will completely destroy that. It uses a very strong acid like chromic, and it completely destroys that sample. And then you determine how much oxygen was necessary to do that. Does that tell you how much biogas it makes? No, right? Doesn't tell you that, because the biogas is based on what the bugs do. So when you're thinking about BOD and COD, I would strongly urge you to think about it the same way, the difference between VS and a BMP. A BMP is based on what the bugs can eat. BOD is what the bugs can eat. BMP is what the bugs can eat, biomethane potential. COD and VS are complete destruction, and you need to know a lot more about the sample before you can determine how much gas it's going to make. Now, in certain areas, in municipal wastewater, in wastewater, like I'm going to talk to you about a plant over in West Michigan, in those types of applications, we know that BOD is the majority of what's coming in, biological oxygen demand, and that's how we actually sized that facility when I built that 34 years ago. So couple curves. Take a look at that. Notice the difference here, that the bugs are doing the work, right? And see the curve for the food waste. It's on the left side of the screen. You see it's very fast. It comes up. That's because there's sugar in that food waste. Take a look at that manure on the other side. See the flatness of that curve? See, that's something that's the bugs are having to work some hard. They're going to have to work their hearts out in there in order to get that all broken down so that they can finally plateau out and get all their energy. I want to strongly use these two curves to strongly let you know something, or make sure you understand something. When you send a sample out, when you get the results back, don't just take them and run. Now, you see these two curves right here? You saw that the standard curve that I showed you before for manure should be a long slope. And then you get this curve back, and this is manure also. And your end number, say 350, is not so bad on a liters per kilogram of VS added. But take a look. It actually came up, and in around 7 days, it went flat. That should tell you something's wrong. Either something's wrong with your sample, something's wrong with the seed, something didn't happen, because manure shouldn't climb that fast and then go flat. On the other hand, if you get and these are both manures that came back from a lab. We had to go back and found out, yeah, there was something got screwed up and got it fixed. And but again, this other one on the right. This is manure also. And take a look at that. See how fast that came up, but it got up over near 1,000 on liters per kilogram TS. It got up to 1,000, right? If you get something up that high, that's grease. That's you're talking rapeseed oil, canola. That's what you're talking about. Just something get that high. Manure is not going to get there. So when you just get a sample back, you get the results. Do not throw your hands in the air and run out saying, "Well, I got my results." Stop and think through it, and make sure that there's not something didn't happen with a sample at the lab, and it's you're going to get bad data, and you're going to go forward on design with it, or in operations. Right, you're going to either estimate too much gas, or you're going to take up too much space in your digester with something that's not going to make energy. So let's talk a little bit about systems control. We rely basically on a few numbers. Organic loading rate. This is actually a FOSTAC that you see the picture of here. It's a FOSTAC system Hawk, I think. But we run on organic loading rate, hydraulic retention time, pH buffers and alkalinity. And I'm going to talk a little bit at the end about trace nutrients. And so let's jump in right away. On organic loading rate, what we're looking at is how much energy can be put into that digester for the unit of volume in a day. Okay, and your organic loading rate is, you should know that. Every digester operator should know it. Some folks will say, well, I'm running a dairy manure digester, and I get the same thing every day, and as long as your loading rate comes in, you should be fine. What you have to be concerned with there is if you start to get like this time of year where you're getting the thaw, water's coming in, right? You're actually getting more water, so your organic loading rate is going to start dropping, right? Because the amount of VS versus the amount of space you're taking up the water will start to go sideways on you. So again, organic loading rate, simple calculation. We take you through this all in operator school, but generally an organic loading rate, we're going to, we can get up as high. I've run some stuff high as up in the 4 5s and 5s when I've got like a consistent feed of some sugars or something like that. And, getting down into food waste, you're going to be down 3, 3, 5, 2.9, someplace in there for your organic loading rate. Hydraulic retention time. Simple calculation again. What we're looking at here is how much time you're going to allow your bacteria and organisms to do their work, right? And this is also then based on how you design all of your downstream systems, because they have to be based on the flows that you're going to get out. So and how your storage is being taken up. So simple calculation, that you take your flow, or you take your volume of your digester or your system, divide it by your flow rate, and that gives you your detention time. Anytime you get confused with this, always think about this. If it's 1 million gallons a day and you're putting into 1 million gallons of tank, it's 1. If it's 1 million gallons a day and 500,000 gallon days of flow, detention time of 2, right? So you don't have to, so don't worry about memorizing the equation. All your engineers on here, I'm sure, are just shaking their heads. But to folks that don't do this every day, simple way to remember it. If it's 1 million gallons in a 1 million gallon tank, it's a detention time of 1. So I put this little note on here about slurry digesters, hydraulic retention times 20 to 30 days. Depending, if you're running a silage digester, you might run more. Municipal digesters doing sludge, they might do much longer than that. Things like, even a project down there at Fair Oaks on the sand separators was running, a lot less than that, down in the 12 to 15 day range. But again, everything was forced over into a soluble side, and so that the system was being forced quickly. We talk about systems controls, pH, buffer, and alkalinity. And Dr. Craig Freer put this together, and it's still one of the best systems that I've ever seen, or best slides I've ever seen for this. Generally we're running in a biological organisms like to live around 7, 6 to 9 is normally where they can be. We have a buffering system, however, and that buffering system is what allows us to take in things that might be a pH of 4, like orange juice. So when you start to think about buffering systems, the blood, your blood has it, your body has a buffering system. If you overcome that buffering system, you die, right? So that's why you had fraternities feeding kids having to drink so much orange juice in a time. Their body reached a point where the buffering system was destroyed and they were gone. It doesn't take long. So again, this is what should tell you that probably the first thing it should tell you is that running a digester based on pH is probably the last thing in the world you want to do. Okay, so when we look at buffering systems, right? And again, I talked about it. Manure has one. Manure has actually 3 buffering systems that are in there. You've got calcium, you've got ammonia, that are all buffering, part of the buffering systems that are in manure. But again, most importantly to understand here, if you're monitoring pH, it's too late. So let's take a look at this next slide, and there it is right there. That shows you. And again, this is from Dr. Craig Freer over at Regenis. Again, one of my dear close friends in this industry. But you can see this is from some of his research, and you see that the volatile acid alkalinity. This is a digester being started up, and you see how that pH is generally pretty flat across there, right? Little high, little just bumping up on 8, but look at how flat that is. But look at your volatile acid alkalinity during that startup, and you see how it's dropping off, and it's going to come down into a number that you'd really like to be, right? Down around 0.3 or so. So again, this is that reason, volatile acid alkalinity. This is why you monitor that, and you're going to check pH on a daily basis, because that tells you some other things. And as an operator, you need to know that. You need to know if you know you're watching that. But your most important thing, volatile acid alkalinity. Again, dairy farms, not as important. When I ran food waste digesters at Michigan State here, or out east, we were running volatile acid alkalinity on a daily basis and plotting that and watching it consistently for any perturbations which might indicate a problem coming. I wanted to talk about, again, in 30 minutes, we can't do a full operator school here. What I wanted to tell you about is, I know that lots of folks are getting, you might sooner or later, if you've been operating a while, somebody's going to come up and say, well, I think you might need some trace nutrients. And Dr. VP Tail over at Chemtron Riverbend, used this slide for one of our continuing education courses. And I really wanted to get this out to folks, especially this group. Spend some time, and I would strongly recommend you read this paper. It's the one that's referenced there, or get this book, Trace Elements and Anaerobic Biotechnologies. 2 excellent reads that will really help you understand this process. But what do you see there? Pretty interesting, right? What's the greatest, the most prevalent metal? It's iron, right? But look at those, look at that nickel and the cobalt pathway that's important, right? So just a small amount, and zinc and molybdenum being the other ones. But again, it's rare if you start to run into situations where these micronutrients are missing. Understand if something goes wrong, generally don't look to micronutrients first. Send it out, get a sample, look at what your nutrients are, and then you can start to make an informed decision, as opposed to just buying a nutrient package immediately and putting it in your digester. Okay. So let's go back now. Paul, I got 1 minute, or do I have a few more? You're going to give me a little more leeway.
Yeah, we're good, man. You want to preach?
Thank you, my friend.
These people are just they're volunteering to hang out with us, right? If they want to bail, they can bail. We're not forcibly holding anybody here. We're just luring you in with your charm and your intellect.
Well, thank you, my friend. That's you're way too kind. I made all this up out in the parking lot before I got in the office today. But when I think about key insights for daily operations, some of the worst horror stories that I ever lived through and they weren't on a dairy farm, but they were in dealing with food waste digestion, where people bringing us things were either unknown, it was a new provider, or it was a new driver. And I'll never forget out in down in North Carolina, where the driver shows up, and we started sampling. We always took a sample off the bottom of the tank, the back of the tanker. It was supposed to be DAF float from a chicken processing facility. Run it, pH is at 4. We're like, well, that's a little bit too acidic, but maybe give it, let it run for another minute, then pull another sample. Second sample pH was 2. And they had actually sent us a clean in place, a high acid clean in place, and told the truck driver to see if he could dump it without anybody finding. This could have blinded somebody. That truck got turned around and had to go all the way down into Georgia to be disposed of. So knowing your customers, control of those customers, right? We had, again, another one was grease trappers that were bringing us Porta-John waste. So set yourself up. If your engineers out there, if you're taking in run-of-the-mill food waste, you better have some tanks to pump that into and take a look at it before you let it go right into your digester system. And again, up in Wisconsin, we ran into problems where a local place that made vodka was sending us, was trying to send us out boiler blowed out. No energy in it. Actually would have would have caused more problems. And so make sure what you're accepting is going to be for your digestate health. As far as the most important things you can do, I believe, on a digester is not only monitoring your system controls and checking your ports, it's walking the site and it's talking to every one of your team members every day. And you say, well, geez, Bernie, we all knew that. Well, you'd be surprised at the number of people that try to run a digester and try and run it from a remote location and don't take the time to talk to every person on that site every day to make sure that anything they might have seen, especially from an odor potential, talk to everyone, get engaged with your site. I wanted to add a little bit about certification and continuing education. We are pushing really hard, and I wish I could have all of you come with me onto the Hill when I go back out there in another week and go up and down the halls of Congress, because when you're telling people about getting operators certified and creating careers, it's just a huge boost, right? The benefits of certification and career in career education, right? Increase productivity, you decrease your turnover. We have the operator school. We have continuing education courses. We also now require that you get OSHA certifications and lockout, tagout, confined space, and a Red Cross certification for CPR. I say all this because of one thing, and if you've ever heard me speak, in 9 times out of 10, I'm going to add this in, that the rising tide is what lifts all boats. And I believe strongly that education and teaching our operators, those operators are the folks that are going to make sure if this facility is going to run or not. So getting them educated, keeping them educated, and making a career for them be the most important thing the owner or the engineer can do in order to make that facility prosper. So a couple random closing thoughts. I found this cartoon and just loved it. Again, as I said before, nothing can replace that hands-on approach with a good maintenance management system. New employee doctrination. Never, ever, ever stick a new employee out on the site and figure they're going to learn it. Take them immediately and do a walk down with your up-to-date P&ID of that entire facility. I strongly urge this, that operators must be part of your process hazard analysis and use that process hazard analysis to do all of your N1s, for when you want duplicate systems on the site. More than anything else, remember this, that this industry is run by a bunch of bugs, Bernie's bugs, and there's no negotiating with bugs or with physics. And in the end, you should always be like Bob here, our guy pushing it around. So very, very quickly, I want to show you a couple projects that I worked on This was my first digester all the way back to 1991. She's still running today. My son, who put most of these slides together, James Sheff, was born the day we started filling this all the way to 91. So you see the wastewater treatment facility there. We come out of the slaughterhouse. We go into the covered lagoon. This thing runs 24/7, 365, and we run an 8 megawatt peaking facility, and that facility to this day is churning along doing its work. Had a mixing system, and all the way back in 1991, we put a mixing system in it to make sure that our sludge wouldn't settle in the bottom. This is a really cool project that I was so honored to work with Mark Storman. One of my great, one of the honors of my life was working with that gentleman and building this project over here, over down in Indiana. The first few years, Mark would call me and say, "Well, Bernie, we've been up for 2 years. We've knocked 3 million gallons off. It's 3 years. It's 4.5 million gallons. Now we just say it's 1.5 million gallons a year of diesel fuels knocked off that I-65 corridor by this facility." Another project that was really honored to be able to work with back when I was with Energia, it was this facility has turned along. It's over at MSU. Again, it's because it's my alma mater doesn't mean I'm about to well up in tears right now, but I'm real proud of this facility. It takes food waste in. You can see that we take both manure from the dairy and from the hog operations, and the horse barns all come over here, plus food waste from the Meyer stores and all the university kitchens. So in the end, as I said, I want to thank ABC, Dr. Craig Regenis, or Dr. Craig Freer from Regenis, VP Tail, a dear friend, and Wee Lau from ADRAC, and of course Burns McDonnell, and my son James Sheff, who put all these together. So with that said, I see there's a couple questions. Are they all about how?
I think we're doing okay. The only next question was, is the MSU facility still running? And the answer is,
it is right now. They took down the top two. We had some perforation after 10 years in the top band. So the top bands of the top two panels all the way around have been replaced, and the system, I think, is back up and running. If not, it's going to be back up and running rather shortly. I drove past it last Saturday, and the top is back up and on and inflated. So I didn't see any gas. I didn't see any gas coming out of the top of the engine, but that's the reason it was down, was to replace those two top rings. We feed the top with oxygen, and so that does, you will get some acid formation up in there. And so we had some perforation after 10 years. We had some perforation starting to form up in the top band of the tank. And so again, replace those, put her back on, and she's going to be part of the whole new digestion system that's starting up with the new dairy farm. There's a whole new dairy expansion going on, and the digester will be part and parcel of that. What else?
We're good. We're good. Thank you, sir, for your wisdom. Did you want to address that last MSU question?
No, I didn't see it. Where is it?
If the MSU digester operates with 50-50 manure and food waste, oh, that was just a statement. It does, apparently.
It does. Actually, it goes a little bit. It's closer. You can get down to closer to 30% manure.
Yeah. Yeah. Okay. It's a bit of a rhetorical question.
Yeah. No, it can run. It has run less than that, especially when the students all come back and we get that initial rushes and things. Christmas and times around there when you've got a lot more food waste being generated at the Meyer stores, or grease trapping and things coming in, she will push it up higher.
Okay. Thank you, Bernie.
Anything else? No, we're good.
We're good. Hate to say goodbye to my 41 new closest friends that have been hanging out with us to the bitter end. So thank you, everybody, for sticking out all of day one. Bernie, thank you for your wisdom. Thank you for your service. It's my pleasure to be tribal elder side by side with you, kind of driving this industry. Everybody needs to send their operators to Bernie's school. If you've got a screwed up digester, be sure to give Bernie a call.
Yeah, please. If anything else, if you just want to talk about digesters, that's also good too. So
go Spartans and
go green. All right.
Thanks, everybody. Hope to catch you tomorrow on day 2, but day 1 is a wrap. So long, everyone.
Thanks. Bye-bye.